Here we have a very interesting question. We are given a square A, B, C, D. There are two circles. A bigger circle, let us name it C1. A bigger circle which circumscribes the square. A smaller circle, we will name it C2, which is inscribed inside of the square. And what do we have to find out? Suppose the area of the first one is A1 and the second one is A2. What we have to find is the ratio of these two areas. Now the square is same. The square ABCD is same. I have just drawn the two figures separately. Let us start with C1. We have to find the area A1 of this bigger circle. Now tell me, which quantity does the area depend on? It depends on the radius or the diameter. Now what is the diameter of any circle? The diameter of any circle is the longest chord in that circle. Now when you consider A, B, C, D, which is the longest line that you can think in a square? If the square is of the side A, then what about its diagonal? Its diagonal is always longer than its side. What will its diagonal be? Do you remember? We have studied it in the earlier classes. It is root 2a. How do you get that? Do you remember the proof? All the four angles of a square are 90 degrees, which means this is 90 degrees. If both of these sides are A, then the hypotenuse, this acts as the diagonal acts as the hypotenuse. So when you apply the Pythagoras theorem, the hypotenuse will be square root of 2a square, which in other words is this. This is how you get the diagonal, and diagonal will always be greater than the sides. Now the diameter is what? It is the longest chord of the circle, or in other words, what is it? It is the diagonal of ABCD, which is what? Which is root 2a. Now what is the area? It is pi r square, which means pi, remember to divide it by 2, then square it, then you will get pi a square by 2. So this is the area of the first circle. Now let's move on to the second one. Now in C2 the same thing follows. Diameter is the longest chord. Now which is the longest side of a square? There is no such thing. All the sides of a square are of equal length. If this is A, all the four sides will be A. Now here, why can't we take the diagonal here? If you see, if you join the diagonal, what will you see? It is lying outside. What we need, the diameter should be the chord of the circle, right? But here see, it is going outside the circle. So here you cannot take the diagonal. Here when your circle is inscribed inside of a square, you just have to be happy with the side. It's the side of ABCD, or in other words A is the diameter of C2, which means what is the area, which is A2, what is it? It is pi a by 2 the whole square, which is pi a square by 4. Now what was our question? We needed to find the ratio of A1 is to A2, which means what? Pi a square by 2, and the other one was pi a square by 4. Then what is the answer? So this is the result that we were looking for. The area of the bigger triangle is 2 times the area of the smaller triangle.